fossils act The history of life on Earth is a mystery that biologists and geologists have been trying to unravel for hundreds of years. The most important clues to this mystery are fossils. In order to understand how organisms evolved through time, we have to know when their fossils formed. Fossils form when organisms are buried in sand and mud. As layers of deposits build up, older sediments are compressed into rock. The organisms form fossils within the rock. The younger the rock, the higher it is in the rock layers. The fossils within the rock layer are the same age as the rock itself. In studying the Earth, scientists discovered that similar fossils appeared in a consistent way through the layers or strata of rock in different locations around the world. These fossils acted as an index to the time the sediments of the rock were deposited. Comparisons could be made between buried rocks based on the fossils within it. In this way, scientists were able to develop a geological timescale. Important events in the history of life, like mass extinctions, were apparent from the disappearance of fossils at a consistent layer in rocks around the world. With a relative timescale, biologists knew the order in which fossil organisms appeared, but no one could be sure about the precise ages of the fossils. Calculating the absolute ages of fossils wasn't possible until radioactivity was understood. The gradual breakdown of a radioactive substance in rocks is the clock that scientists use to measure geological time. In the process of emitting radiation, radioactive isotopes decay into different isotopes, eventually producing elements that aren't radioactive. For example, the radioactive isotope uranium-238 decays into the stable isotope lead-206. Each radioactive isotope decays at a unique constant rate, described by its half-life. The half-life is the time it takes for half of a given quantity of a radioactive isotope to decay into another isotope. The half-life of uranium-238 is 4.5 billion years. That means it takes 4.5 billion years for half of a sample of this isotope to decay away. Consider a rock containing uranium-238 that formed at the time of the earliest known fossils, about 3.5 billion years ago. Today, it would contain 58% of the original quantity of uranium-238. An isotope with a shorter half-life would be better for calculating the age of a younger rock. It takes millions of years for a significant amount of uranium-238 to decay from its starting level. An isotope with a shorter half-life would decay more significantly in a shorter time. The greater change in the amount of isotope would allow a more accurate measurement of the age of a younger rock. Radiometric dating is the method of determining the ages of rocks and fossils using radioactive isotopes. Using sensitive equipment and great care, scientists measure the amounts of a radioactive isotope and its decay products in a sample of rock or fossil in order to calculate its age. With the help of radiometric dating, the relative ages of rock strata and their fossils have been converted to absolute ages, and our picture of the history of organisms evolving on Earth has become increasingly clear and consistent.